All right, so next we've got this weird little function that we are calling g of x. Does not have a formula, it's just a graph, and we are going to be asked to do several transformations to this. So let's start off by looking at g of x as a function. So what is it? It is 3 line segments, and we have some points that we can identify on this graph. So I've got this point, this point, this point, and this point on g of x that I can pretty much make into an ordered pair. So I have my x and I have g of x. So when x is negative 2, g is positive 2. We've got the point 0, 0, the point 1, 1, and the point 2, 0. So next we're going to talk about vertical stretches and shrinks. So here's our g of x. The first one says 2g of x. All right. So f of x equals 2g of x. Now, I find it easiest if every time I do one of these transformative functions, I refer back to my original set of points. Remember, anything that happens to the outside of the function, that's going to affect the g values. Anything that happens to the inside of the function, that will affect the x values. So x, and then we've got 2g of x is our f of x here. Since there's no effect at all on the x functions, my x values are going to be the exact same as they were in my original function. Now my g values, they're going to change. Every one of my g values is going to be multiplied by 2. So instead of 2, I'll have 4. Instead of 0, I'll have 0. Instead of 1, I'll have 2. Instead of 0, I'll have 0. So let's take this. And on the same graph that I had before, I'm going to put this in orange. And I need a slightly larger 1, 2, 3, 4. So I've now got the point negative 2, 4. The 0, 0 point, the 1, 2 point, and then the 0 point. That's still the same. And what I can see is that this new 2 times g of x function looks just like the original function, only it's been stretched by a factor of 2. Our next one is 1/2. So I'm going to graph over here just to save the integrity of that graph. Again, we have in this next one, I've got f of x equals 1/2 g of x. So nothing at all is going on with my x's. My f of x, so my x's are negative 2, 0, 1, and 2. I take each g of x value that I started with, I multiply it by 1/2, so that becomes negative 1, 0, 1/2, and 0. Negative 2. I don't know where I got that negative from right there, but I'm going to erase it, right? That should be negative 2, 1. So negative 2, 1, 0, 0. 1, 1/2, 2, 0. And now I have the I'm going to have to edit that a little bit, but that's okay. So now this is 1/2 of what it was in the original function. We've got f of x equals g of x plus 2. So f of x equals g of x plus 2. Now here there's nothing done to the y, there's nothing done on the outside. So in this case our y values, or our f of x values, they're going to be the same as they were over there. So I've got 2, 0, 1, and 0. Our x values are going to be shifted to the left 2, right? Remember, adding 2 shifts to the left 2. So we know that if I take negative 2, shift it to the left, that'll be negative 4. 0 shifted 2 to the left will be negative 2. 1 shifted would be negative 1, and 0. Now, the other way you can look at that is new x versus old x, right? So my new x, my new value is x plus 2. How do I make that x plus 2 equal my old value? Well, that's going to happen when x equals negative 4. Right? My new is x plus 2. My old value was 0. Talking about this second point. So that would mean x is negative 2. So you can look new value versus old value, and when they get a little more complicated, this is very, very helpful. So what I'm basically saying is you take whatever's inside this argument part and you set it equal to these x values, and that tells you what x value to put in. So you take this, whatever the new argument is, you set it equal to the old x value, and you use that to calculate the new x value. Once I've done that, 1, 2, 3, 4, 1, 2, 0, 0. Oh, not 0, 0. Erase. 1, 2. Negative 2, 0. Negative 1, 1. 0, 0. Same shape. Exact same shape, only now it's been shifted to the left 2. F of x equals g of 2x. We know from our notes that when we do it inside, multiplying by 2, that should be a horizontal shrink. So the points should be closer together. Nothing is done to the outside of the function. So right off the bat, I can just put in my same values here, 2, 0, 1, 0. Now, new x, old x, right? So my new x, 2x, equals negative 2. X equals negative 1. That's the value that goes there. 2x equals 0. X equals 0. 2x equals 1. X equals 1/2. 2x equals 2. X equals 1. Here are my new points. Negative 1, 2. 0, 0. 1/2, 1. 1, 0. Same height. The points have just been compressed in. That is a horizontal shrink. Now, one of the tricks with these is knowing what's going to happen before it happens. Here, we've replaced the x with negative x. That's inside the parentheses, so we know that it's going to be something horizontal. And in this case, when we replace x with negative x inside, that is going to be a horizontal reflection. In other words, it's going to flip over the y-axis. Notice nothing has happened to g. Nothing has happened to the outside. So right off the bat, our 2, 0, 1, 0, those are the same. But now what value of x, new x, old x? Negative x equals negative 2, x equals 2. Negative x equals 0, x is 0. Negative x equals 1, x is negative 1. Negative x equals 2, x is negative 2. Then we plot these points, and we see it's the exact same function we had before, only it's been flipped over the y-axis. All right, next we have negative 2g of x. All right. Next we have f of x equals negative 2 g of x plus 1. Nothing is done to the x, so negative 2, 0, 1, 2. Now with the g, we're going to take g of x, multiply it by negative 2, then add 1. So starting with the 2, negative 2 times 2 plus 1. Negative 4 plus 1 is negative 3. 0 times negative 2 is 0, plus 1 is 1. 1 times negative 2 is negative 2, plus 1 is negative 1. And then 0 plus 1 is 0 again. Negative 0, 1, 1, negative 1, and 2, 1. Notice this thing has been stretched and flipped over and shifted up. So it had a whole lot going on in that one. Here we see that then this is the first time we've seen an example that g should be an x. This is the first time we see an example where we have something done to the horizontal and the vertical both. So what we need to do is just work them individually, right? Work the x and the y separate, or the x and the g of x separate. So here's what I mean by that. New x, old x. So x minus 1 equals negative 2. X equals negative 1. X minus 1 is 0. X equals 1. X minus 1 equals 1. X is 2. X minus 1 is 2. X is 3. Now we move on and we look at what numbers go along with those. We're done working with x. Now we look at our g's. So we take our g of x, multiply it by a half, add 2. 2 times 1 half is 1, plus 2 is 3. 0 times 1 half is 0, plus 2 is 2. 1 times 1 half is 1 half, plus 2 is 5 halves. 0 times 1 half is 0, plus 2 is 2. Negative 1, 1, 2, 3. 1, 2. 2. 1, 2, 3, 4. 5 halves would be 3 1/2. And then 2 again. And so this thing has been horizontally compressed and moved to the right and up, but it still has the same basic shape, that went a little bit too high, that it had before.